From the beginning of time, beginning of time, man has left his mark graphically. First with paint, and then with ink. "500 years of printing history have led to today's dominant technology, offset printing. In our daily lives, we are surrounded by offset printed goods, which generate over $600 billion in annual revenue. But society is changing at computer speeds. Digital media is rapidly replacing many traditionally printed products. What does all of this mean for the future of printing?"
What does all of this mean to the future of printing and to your future? Ladies and gentlemen, my name is Benny Landa, and I'm really thrilled to welcome you all here today. Now, I want to make a special message to those of you standing outside the theater. We simply have been sold out for the next 3 days, and I hope you are able to enjoy the presentation nevertheless. Many of us have met in the past, perhaps at Drupa 2000 or Drupa 95, or maybe even at IPEX in 1993, when I had the privilege of unveiling the world's first digital offset color printing press as the founder of Indigo. Those of you who were at any of those previous events may remember me saying, everything that can become digital will become digital, and printing is no exception. So, has printing become digital? Well, certainly, many printed goods are produced all digitally today, such as photo albums, short-run label printing, trans-promotional printing. In fact, since we launched it in 1993, the digital printing industry has exploded, producing today 1 trillion pages a year of digitally printed goods. Despite that, digital printing has only nibbled around the edges of mainstream printing, which produces 50 trillion pages a year. That is the reason that we developed nanography, to go after the mainstream, the other 98%. Now, as the name implies, nanography is based on nanotechnology. Nanotechnology is the science of ultra-small things. To give you some idea of what 1 nanometer is, how small it is, imagine if this golf ball were 1 nanometer in diameter, a single human hair would be 4.2 kilometers in diameter, 3 times the diameter of the entire drupa messe. Now, why is society so interested in nanotechnology? Well, when you make things nano-size, often their properties change. Metals drop in melting temperature. Other materials become super hard and can protect surfaces from abrasion. Yet other materials can be rapidly absorbed in the bloodstream, opening up new avenues to drug delivery systems. And what we at Landa have discovered these past 10 years is that when you make pigments into nanopigments, they also acquire extraordinary properties. They become extremely powerful absorbers of light, for example. And that is why we have incorporated nanopigments into nano ink, and nano ink is at the heart of Landa Nanographic Printing. What are the characteristics of Landa Nanographic Printing? Well, some of them are quite hard to believe. Nanography enables you to go at very high speed. It gives you the broadest color gamut of any printing process. It provides very high density. It enables you to produce the sharpest dots of any printing process with very high gloss on any kind of paper, coated or uncoated, untreated paper, and all plastic packaging films. It enables you to produce abrasion-resistant ink, cost per page lower than any digital printing process, with the smallest footprint, low energy consumption, and what for me is the most important of all, 100% green. So now, ladies and gentlemen, let's have a closer look at nanography. To do that, I invite you to join me in the wonderful world of nano.
Hi there. Here we are, down in the depths of a sheet of paper, waiting to be digitally printed by inkjet. Though we are sheltered by all these paper fibers around us, they'll be of little protection. For when the dreaded drop hits, it will be like a tsunami, a tidal wave torrent that will drench the paper fibers and will mercilessly drown any nano folks like us. So we'd better get out of here. You see, when printing processes apply ink to paper, the wet ink penetrates the paper. Now, this is true for all printing processes. In the case of inkjet, however, there's so much water in the ink that the paper becomes totally saturated. But paper and water don't mix. The paper gets swollen, deformed, and cockled. The consequence of all that is that you have to heat up all that water and paper to dry it out again. And that consumes a tremendous amount of energy.
Now that we've shown you how inkjet printing works, we're now going to give you a look at how Landa Nanographic Printing works. So just watch.
Nanographic printing begins with the ejection of billions of microscopic droplets of Landa Nano ink onto the special image conveyor blanket. Each row of ink ejectors adds its own color of nano ink. Each droplet of nano ink lands at a precisely designated location, blending with other droplets to create the final colored ink image. As each droplet lands on the heated blanket, it begins to spread and lose its water, becoming thinner as it does so. When all of the water has been evaporated, the ink becomes an ultra-thin, dry polymeric film. Let's look again. As the nano ink film spreads and dries, it becomes only 500 nanometers thick, the thinnest ink image of any printing process. The completed image is now ready to be transferred. Because of its unique properties, nano ink images have the amazing ability to bond tenaciously to any paper or plastic without penetrating the substrate. Upon transfer, the nano ink film instantaneously bonds to the paper, forming a tough, abrasion-resistant laminated layer, leaving no residual ink on the blanket. Nano ink images can be transferred to sheets or webs of ordinary coated or uncoated paper or plastic packaging films without any kind of pretreatment. Since nano ink images are already dry, there's no need for any kind of post-drying. So two-sided printing becomes simple, and printed goods can be immediately processed right out of the press.
So now that we've shown you how the printing process itself works, I'm sure you would like to see some images. After all, that's what printing is for. So we're going to compare printed dots the offset printed dots with which you are so familiar, with inkjet printed dots, with nanographic printed dots, in this example, all on uncoated ordinary paper. Have a look.
Offset printed dots have poorly defined edges and non-uniform density. Inkjet printed dots are even more ragged with poor optical density. And this is nanography. Note the extraordinary edge sharpness, high image density, and uniformity. Such a startling effect deserves a more in-depth explanation. You see, as the ink penetrates the paper, much of the pigment ends up below the surface, reducing optical density and uniformity. And just as ink gets absorbed into the paper fibers, it also wicks along the paper fibers, making the edges ragged. With Landa Nanographic Printing, a dry ink film is applied to the paper, so there's no penetration and the edges are super sharp. Since these ultra-thin film images are literally laminated to the paper, they conform to its surface roughness, right down to the topography of individual paper fibers. This accounts for nanography's extraordinary ability to match the gloss of the paper, whether coated or uncoated. Unlike conventional inks, in which the pigment particles are many hundreds of nanometers in size, Landa Nano ink pigments are merely a few tens of nanometers. These nanopigments are not only super efficient absorbers of light, but they also don't scatter light. These properties give Landa Nanographic Printing the broadest CMYK color gamut of any printing process.
So what we have seen is that the thickness of the ink film has a profound effect on the properties of the printed page. And thinner is better. But not just for the printed page, also for the pocketbook. The thinner the ink image, the less material is needed to produce it, and the lower is the cost of printing. And what you can see on this slide is a comparison of various printing processes. The cost relationship between the different processes is just a linear function of the thickness of the ink. So that explains why Landa Nano ink printed images can be the lowest cost digital printing of all. Now, many have asked me, why did you develop nano ink with water? And why isn't it solvent-based or UV-based? And the answer is very simple. Even if our customers could afford it, our planet cannot. And that is the reason that Landa Nano ink is based on water, pure, clean water. Water is environmentally friendly, it's plentiful and cheap. And now, ladies and gentlemen, time has come for me to give you a brief introduction to the entire family of Landa Nanographic Printing presses.
The Landa Nanographic press lineup comprises 3 sheet-fed presses and 3 web presses, spanning the entire range of commercial printing, packaging, and publishing applications.
For an in-depth look at our entire press lineup, I invite each and every one of you to join one of our product demo tours out in the product arcade. And now, ladies and gentlemen, for the moment you've been waiting for, I want to introduce you to the stars of our show, the Landa S7 Nanographic Printing Press and the Landa W50 Nanographic Printing Press. And to present some of the amazing features of these products, I would like to introduce you to Robin Walton, my dear friend who's been with me at many drupas in the past. Robin, it's all yours. Robin will be assisted by Shai and Ilan, and I will be back.
Definitely. Thank you, Benny. Let's take an inside tour of the Landa S7 Nanographic Printing Press, our B2 8-color perfector, capable of printing at speeds of up to 12,000 sheets an hour. All Landa nanographic printing presses have two things in common. They come in 4 to 8 color capability, and they all have the most amazing user-friendly touchscreens. When it comes to particle size, smaller is better. But when it comes to touchscreens, bigger is better. And this 3-meter-long interactive display with its intuitive man-machine interface allows even an untrained operator to quickly become a master. The machine controls appear both on the right and the left hand of the press, enabling the operator to run the press either from the feeder or the delivery end of the press. And the right-hand portion of the monitor is concerned with job management. Here the operator can change the print queue both in a graphical and a spreadsheet formation. He can also use the built-in intelligence in the machine to suggest an optimum job sequence for maximum press utilization. And over on the left-hand side of the monitor are all of the machine functions. The live interactive display gives a real-time look at what's going on inside the press. And we have cameras mounted behind the scenes so that the operator can see real-time what's happening with the feeder, the image transfer, and the delivery into the press. Every function, such as ink supply, paper supply, and operational status, are displayed in clear and intuitively comprehensible graphics. And to round things off, here is the Landa W50 Nanographic Printing Press, designed for direct mail, trans-promo, and publishing applications, capable at printing at speeds of up to 200 meters per minute. Wow. And let's talk about productivity. These presses are a press owner's and an operator's dream machine. Due to the high degree of automation, a single operator can manage 1, 2, 3, maybe even 4 presses at a time. And when the operator steps away from the press knows and automatically switches itself into vital signs mode so that he can see the key functions of the press from up to 40 meters away while he's taking care of another press or looking at his paper inventory or taking a coffee break. He can even manage the press from his remote touch pad. Very cool. Thank you, Shai. Print samples can be magnetically mounted on the display, and the operator can use his digital wireless loop to examine, record, analyze, and compare the results. Thank you, Ilan. Landa Nano ink comes in 15-kilogram containers that are easily replaceable by the operator and automatically diluted to working concentration using the customer's own water, thereby saving lots of resources by not shipping water all around the globe. Empty containers of nano ink occupy minimum volume and can be recycled along with your beverage bottles. And when it comes to service, there's never been a press with easier operator access. At the back end of the press are slide-out tool drawers with everything the operator needs. And as you can see, Ilan has raised the screen at the touch of a button, allowing him complete access to the entire paper path for jam removal and adjustments. Ladies and gentlemen, I want to reintroduce you to the architect of the first revolution of digital printing in 1993, and here at drupa, the second revolution in digital printing,
Robin,
Mr. Benny Landa.
Robin, you did a great job. Thank you very much. Robin Walton. Thank you. So, what does all of this mean to the future of printing and to your future? Well, if you are in packaging printing, your future looks pretty good. After all, so long as mankind eats, food will come packaged in beautifully printed containers. So your future is bright. But what about the rest of us? What about commercial printers? What do commercial printers produce? They produce brochures, sell sheets, magazines, newspapers, mailings. They produce communication from one person to another. Graphic communication. Is there anyone in this room who believes that 200 years from now, man will be communicating by smearing pigments onto crushed trees? No. So the question we all have to ask ourselves is, when will this happen? When will printed graphic communications be replaced by digital media? Well, you know what? Man has been communicating with paper for over 5,000 years, and with printed paper for almost 600 years. So it will take many decades for printing to be replaced by digital media. The real question we have to ask ourselves is, how can we prosper as this industry transitions from mechanical printing through digital printing to ultimately no printing, where digital media will replace it. Now, I know you are all saying to yourselves, oh, I know this guy, he's going to say, we should become a digital print shop. That's how we'll prosper. And if that's what you're thinking, you'd be wrong. Not because digital print shops aren't doing well, they are. They're making money, they're growing, they're doing very well. But it's the 98%. That's where the real opportunity is. And you know where the 98% is right now? You already have it. It's in your print shop. You just can't make any money from it today. Today, each of you has offset presses. Those offset presses are not going to be challenged by any digital printing technology for the foreseeable future for run lengths that are millions or hundreds of thousands long, or even tens of thousands long. The trouble is that your customers, the market, is demanding ever shorter and shorter run lengths. And since every offset job requires a complete set of printing plates and make ready, you can't make money. You can't be profitable at these short to medium run lengths. That's why digital printing was invented. Profitability from a run length of 1. Trouble with today's digital printing, however, is that the cost per page and the limited format size and the limited speed means that as digital printing increases in run length, it too becomes less profitable. That leaves an enormous gap where neither offset nor digital can be profitable, and that gap, short to medium run length printing, that's where you need to be, because that's where the market needs you to take them. That's where Landa Nanographic Printing comes in. We fill that gap. Nanography is profitable from a run length of 1 through many thousands of B1 sheets. Many thousands of B1 sheets. That is where the huge opportunity is. Now, ladies and gentlemen, if you find this interesting and you're interested in a Landa Nanographic Printing Press, I have to tell you, we aren't going to be shipping to customers until the end of next year. The reason is very simple. Perfection. Your customers expect of you perfection. You expect of us perfection, and that is what we will deliver. Print quality has to be perfect. You'll see our print quality. It is not yet perfect. It will be. The machines look fantastic. They're not yet reliable enough. They will be. That requires many, many months of testing. And when we ship, we will be shipping supremely reliable, high-quality products. However, today what you can do is you can secure your place in line to one day receive one of these presses by speaking with one of our Landa representatives. They'll be very happy to help you secure your place in line when the time comes. Now, ladies and gentlemen, is that enough for you to decide to buy a nanographic press? I'm sure not. And the reason I'm sure not is most of you are small family businesses. That's the nature of commercial printing. For you to invest in a printing press of any kind is a huge risk. You might have to mortgage your house to pay for it. You might have to borrow from your mother-in-law. If you make a mistake, this mistake not only jeopardizes your livelihood, it could jeopardize your marriage. This is a real serious decision. You can't afford to make a mistake. So how do you know you're buying the right technology? Well, we've thought about that, and we've said to ourselves, there's only one way to know. That way to know is if every major press manufacturer in the industry embraces nanographic printing, and there's industry-wide adoption of one technology, everyone is saying the same thing, that should give you comfort, and that's what's happening. We have entered into global strategic alliances, and the following companies have announced that their next generation of digital printing presses will also be based on Landa Nanographic Printing. They include Komori, Heidelberg, Man Roland, and there are more yet to come. The reason we've done this is we know that for you to feel secure that you are making the right decision, we need industry-wide adoption. Everyone has to agree, yes, this is the right direction, and then there's no confusion with one company pulling in one direction, another pulling in another. Now you can rest assured the next generation of digital printing will be based on nanography. So I hope you all make the right choice. Ladies and gentlemen, before you leave the theater, I have two more messages for you. The first, on your way in, each of you received a souvenir, genuine, fake leather briefcase. Please don't forget it in the theater. The second thing I ask of you, please don't leave the theater until you see a message I've prepared for you. It'll appear on the screen, you'll recognize it. And lastly, I hope you've enjoyed our presentation. And I do hope each of you leaves here saying to yourself, wow, I have seen the future, and it's worth waiting for. Ladies and gentlemen, I thank you very much.